Okay, hi everybody, and welcome to the talk Code Security Reinvented and Navigating the Era of Artificial Intelligence. Out of curiosity, how many people have attended my talk at 11 o'clock this morning? Let's see our retention rates. Okay, we are strong. Perfect. I'm Joseph, and I come from GitHub, the platform where 100 million plus developers are building, scaling, and delivering secure software. And specifically, I'm coming from the GitHub Security Lab, which is a team of security experts with the mission to secure the open source software that we all depend on. And I want to give you some numbers in regards to our impact. In the past 4 years, we found more than 1,000 security issues for which we had 700 plus CVEs. And we work with developers to fix those. And we have a fix rate of 96% for these CVEs, which is hard to achieve because we are talking about two different worlds, the world of security people and the world of software developers. And this is the main point I would like to make today through the real practical use case I'm going to show you. We know that there exists one application security specialist for every 100 software developers. And this gap is behind a lot of security issues we are facing nowadays because we don't have enough security people. And you know, before AI, you have to have a person to be the security expert in a company. So food for thought for today, at the end of the talk, think about it on whether artificial intelligence can help us bridge the gap between one application security specialist and 100 software developers. Today I'm here to show you 4 practical ways to do so, but let's keep up with the introduction. So the good news, and what I'm trying to say, is that the world's collective security knowledge is out there. Is in the books, tutorials, the knowledge of a security expert. And with AI, we can have this knowledge in our fingertips, which was not a thing in the past. And you know, before ChatGPT, some daily applications were like assistants. Then ChatGPT came in our lives. Oh, hi, interesting. ChatGPT came in our lives, and you see the word AI everywhere. Like I can hear it in buses, airports, and so on. But before, nobody knew about it. Like I had an interview exactly 10 years ago, and it was all about AI. And then my mom asked me, did it go well? And I was like, not really. I didn't know a lot of things about AI. And she was like, what is AI? But now everybody knows what is AI. And some future applications for mass consumption include things that are embedded in our life. And I show you these last 3 pictures because I want to draw a paradox. How many software engineers are behind these thousands, if not millions of software engineers, right? But until very recently, these software engineers had any AI behind them? Did they get help from AI to do what they do best, to write software? No. So until very recently, there was no AI to help these engineers do what they do best. Until Copilot was out, that is the world's leading AI pair programmer. Who here is using Copilot actively? Cool. You are in the right talk. For those that haven't at the back, I would like to show you a quick example that I have pain before Copilot. So here is me trying to validate a US phone number, and I have to Google this one, this huge thing you see here called regular expression. I have to write it, I have to test it, and the whole thing will take me a lot of minutes, okay? And it's not something I enjoy. I actually hate it. And other people also do. And that's why we have, at the end of last year, and I'm going to have the new figure very soon, 60% of all the code that was committed at GitHub was Copilot generated, and we are talking about billions of lines. And the year before, this was 35%, so it jumped. And you know, in companies around the world, like Mercado Libre, which is a large e-commerce website in Latin America, is the Amazon of Latin America, according to New York Times. They are super happy with their productivity, and I want to give you a scale of this company. They have, in their whole company, 13,000 developers, 9,000 of which are using Copilot, and they have 50% reduction in time they spend to write code. The only reason I show you this stat is because I want to use it at the end of the talk. So maybe they use this 50% to do something else. Okay. Oh, and they are merging 100,000 PRs per day, even before Copilot. So it's a big company. Cool. Today we are here to see 4 ways that developers can use artificial intelligence to leverage the world's security knowledge. Whatever I'm showing you today, you can do it 1 second after or during the time I speak. Everything is publicly available. These are the ways that I found with my company, with my team, and the people I speak around the world that you can use AI for security. Starting from writing safer code. This one is good because you can start security from left instead of shifting left. If you shift, there's always some gap. If you start from left, you start strong. Let's be practical today between us. Okay. Have a look and let me know what can go wrong here. Let's have a volunteer. Okay, the gentleman at the front is kindly saying SQL injection. Which line? 23rd. And it's correct. Okay, we are gonna use this example throughout because it's easy, okay? So let's see how someone could exploit this. Instead of passing a real username in here, they could pass SQL language, but in a malicious manner to drop a table or to create an admin user or to drop like a logic bomb. In general, I'm gonna keep it simple to make the points I want to make. Other vulnerabilities can fit the same examples I give you today. Let's get a bit more advanced. I'm gonna use Copilot here. I'm deleting the code and I'm having new code being suggested. And here Copilot is giving me what we call parameterized statements that I tell you, you can't really have the same problem if you pass the code, right? Is anybody here having some objections with the code you see on screen? Perfect. Okay, the silence is the goal. And I'm so happy that when I ask these questions in rooms around the world, there's the same silence. What does the silence say in a business environment? I'm a developer and I want to ask if my code is okay, safe. Well, maybe I'm a junior developer, okay? And I don't have the guts to ask you this question because maybe I'm afraid of like you thinking I'm stupid or whatever. Or maybe we don't have enough people in this company to answer this question. They don't have the skills maybe. Let's ask someone else. Okay, so because this is a bit down, I'm asking, is the code fully secure now? I was thinking that as the code is implemented in JavaScript, in line 22 here, an attacker could pass an object as an input instead of a string and still achieve SQL injection. Can you provide me with an additional control to prevent that from happening? So I'm having the, yes, you are right. You can have here an expression, a regular expression to make sure that what is passed in this variable here is indeed not an object that is then gonna be casted into a string and still achieve SQL injection. That's good, right? Because I had somebody to help me with that. I'm not here to tell you AI is perfect. I'm just slowly developing my point. So let's understand the problem first, okay? What caused the issue we saw was that The developer in this case, which is a problem we see very often, has deleted the vulnerable code. I mean, the alert, you get it for line 23, right? And then you have code being implemented straight away. But the mistake here is the context first and then the space. What do I mean by the word context? I didn't write any instructions, any logic in the form of natural language to make an LLM use their own reasoning and bring down a better suggestion. And the second problem was space. I gave this space from line 23 onwards, so my pair programmer, it doesn't matter if it's Copilot, it can be ChatGPT, it can be whatever, okay? The talk is agnostic. I'm having the examples in Copilot for obvious reasons. So here, I'm giving this space, so I'm getting instructions back in this space. I don't expect Copilot to tell me, oh, your variable name up the top is not nice and your design is bad, blah, blah, blah. You are not a good programmer, quit your life and stuff like that. So this is how I will do it based on the problems I know so far. So if user is not empty and user is a string, then you can delete the whole thing. And you see here, it doesn't use a regular expression. It's using a different way to achieve the same result, which is to make sure that what you pass is not an object. So it doesn't matter if you do it through a regex or elsewhere. The point is to have the control in what is in now line 23rd, so the parameterized statements that are suggested make sense. Otherwise, it's not a bulletproof security code. And we do more stuff to help with that. We added a security filter in Copilot to block vulnerable suggestions from being suggested to the coder, to the developer. And this is because when Copilot was trained, it wasn't trained in code that was just secure. It was trained in all publicly available code. This includes code that it can be vulnerable, it can be lower quality. However, I'm not here to tell you that we solved our security issues, okay? Nobody's perfect, not even AI. And the best practice is to test all your code, including that code that has been suggested to you by Stack Overflow, Copilot, you name it, okay? And Copilot is not here to replace security testing as we know it today, because they are built differently and for different purposes, of course. So Copilot is designed to predict the next word. In this case, you have a coding keyword, while an advanced security tool that I'm gonna go a bit later in details is having taint tracking capabilities, data flow capabilities, more advanced stuff for security issues. Let's see this new example now. Same code. I'm gonna use the code for the entirety of the talk, and I'm gonna ask this question. Sorry about that. Yeah, the question is, list the security issues in the code. I'm typing very slow. And propose code to fix those, to fix each of them. Okay, that's a prompt here. And here we have, there are several security issues in the code that need to be addressed. SQL injection, passwords in plain text, no input validation. Here is the new code. I'm showing this example because I want to tell you the following. In this specific case, that we have simple, low-hanging fruits or WASP top 10 stuff that Copilot has seen so many times in the training, it's really good in this. But when it comes to things that are like more nested, you need somebody that is more advanced, I wouldn't personally go with any pair programmer at this stage. Even if they become more advanced, it doesn't mean they become more advanced in cybersecurity, software security, code review stuff, okay? And I'll give you a good insight I have from my personal research, which is that here you have some code, okay? If I was importing at the top a known to be secure cryptographic library, and I was then using this cryptographic library in my code in insecure manners, like for example, create some randomness that might not be so random. Then I caught Copilot in the past not sometimes, every time the response is generated. It's not every time deterministic. So I have some cases where Copilot was like, yes, no issues. You are importing at the top a cryptographically secure library, so you are good to go. No issues in the code. Yes, but in reality, I'm using it internally in insecure manner. So this wasn't picked up, but it will be picked up by security tools. So I can't highlight this enough. Copilot is not here to replace security testing, and at the same time, is your co-pilot. You are the pilots. Let's continue with some other stuff. At the same time, we believe that AI is not here to replace developers. This is a statement both from GitHub and also the parent company, Microsoft. Actually, in the public statements, you can see that we believe that Copilot and technologies like this can actually bring more opportunities in technology, create more opportunities for people to work in tech. However, I just said this because I want to mention the human factor. The factor that is humans that introduced the most attacking vectors in organizations according to the Verizon Breach Investigation Report, the VBIR. In 2023, in 2-3 weeks, we are going to have the new one. So, use of stolen credentials, 49%. This is like secrets being leaked. Phishing, 17%. Exploitation or vulnerability, 6%. Let's see how we can use AI in other elements before we continue with Copilot. You can have secret scanning that is used for unstructured secrets. And before AI, we had 30,000 secrets being stopped locally. Like, for example, at the code level, before they leaked online. And the new AI feature is secret scanning for generic secrets, because in passwords, you don't really have a regular expression to track. Therefore, if this is my password, how do you build an irregular expression to use it? So with AI, we can pick these things as well. And these capabilities embedded in Copilot as of our latest announcements, so this can be picked up also when you ask Copilot now. That's a new improvement. Let's continue. The second way you can use AI, is to find a security issue. This is the second one I'm going to show you today. There are other two later on. I would use static application security testing, also known as SAST, to make my points today. And I'm going to use CodeQL, which stands for Code Query Language. Let's understand a bit how it's used, how we can use this language. Who is familiar here with SQL, the structured query language for databases and so on? Most of you. So CodeQL, very similar approach. However, instead of saying from the table users, give me the username, name, the whatever, this time you are querying your own code and you describe what to find in your own code. Such as you can say, find me the functions that accept user input as part of their first index. So you can be very specific or you can keep it generic. Just give me the functions that accept user input. Okay, you can use CodeQL as a consumer. So you just enable it in your CI/CD pipeline, you receive alerts. I have to build this background with you now to make the points with AI. This is how it looks. You just click 2 buttons, you set it up. It knows the languages you use. It's free for open source, so when you have public projects, you can just go on and do it. It takes the language and it's ready. So you go to code scanning, you click here, and you are gonna get the alerts. There's no AI so far. You click in the alerts, you see the severity, and when you see the severity, you are inside a PR, so you can work towards something. You have some URLs to go outside and learn more about the flow. Why should you care? Why shall I spend time today to show you this? Because from all the ways that security vulnerabilities are being found, SAST is accountable for around almost 50%. Other ways can include Copilot told me about it, or pen testers told me about it, or I got hacked and journalists told me about it, or there are many ways, okay? So this is the number one way, and that's why I decided to spend some time today about it. And you know, clients are happy. Back to the Amazon of Latin America, it's a way they use to get to their developers' feedback early so that nothing goes in production. And what is the AI feature we showed with this one? So this is public, it's called Copilot Autofix, and personally, I think it's a game changer. Let's see how it works. Here we have a PR that I used to create personalization for users. I pushed some code, and in the past, I will have to go to the alerts, find what is wrong. Now I don't even have to do anything. I just push code, CodeQL is finding the problems, and Copilot is gonna tell me, you know what? You have a reflected cross-site scripting. This is where it is. This is the source of the vulnerability. Source is where things start to go wrong. Sink is where the bad thing is getting triggered. This is the sink of your vulnerability. You may want to click to see, maybe you are not interested. You can dismiss the alert, but the main thing is that here, the code, the problems is being explained to you. And here you have code that is suggested to you that suppresses the alert. It fixes the problem. So what is in green is the usual new stuff you have with GitHub. You can edit the code that is suggested to you in code spaces. And once you do that, you can commit the code and it's gonna be checked again, or you can commit the fix straight away. So when you commit the changes, you know the alert is gone. And we found that this makes developers up to 3 times faster. It was in beta for like 6 months and is publicly available for the last months. And we saw so much improvement in the data. So here you can see all the files that are changed. You have multi-file suggestions, not just a single file suggestion, to address the security problems and progress. So we believe that this makes developers to start left, not just shift left. And it's part of GAS. So even if you have a Copilot license, to get this, you have to have a GitHub Advanced Security license. But if your project is open source, you get this for free. So you can try it out with public code you have. And this is another example that we use Copilot for. You see this button here called Generate Fix. This is a historic alert, an alert that wasn't occurring because I pushed code. It's one I had from before. I just press the Generate Fix. I have the code being suggested, and I can create a PR out of that. And we had another new announcement. It's called Security Campaigns. It's basically Copilot Autofix at scale for legacy code. There is no public beta yet. So we have GAS and Copilot free for open source. Let's now go to Copilot cases with this SAST tooling. You can take this in your hands and you can write your own queries in case you are not happy with what we give you. So you are more personalized in your own code. So let's understand how it is to write such code. Back to the SQL example I told you from before, you can query your own code. Here we have an example application. It's an Android application in Java. It's just doing a simple username and password authentication. And imagine that me, as a developer now, I want to check, okay, where are these inputs coming from? I just wrote these 6 lines of code, and then I found the methods, the raw query methods, that accept this username and password as input. Final point before going back to Copilot is that there's a huge community, and maybe the code wasn't mine. Maybe I took the code of somebody else. Like, for example, when Log4j was out, somebody creating like a query to pick up Log4j in Australia will make me waking up in Mexico a few hours later to pick up the same problem, because I'm inheriting the knowledge of the community. And let's now see how someone could benefit from that with Copilot. So this is the same code as before. And instead of me going through the knowledge of the community contributed queries one by one and wasting time, I can ask for a short list of what queries that are developed by my team or the community are good enough to start with, so that then I can ask for a customization of these queries in order to be very specific to my own code. Every vulnerability, like SQL injection, is just a name of vulnerability. There are variants of this attack that can happen in dozens of ways. And this is real value for people who want to be very specific, for developers and security teams out there. This is because code is law approach is the only way developers and security people can read the same thing. So this is why we think as a team this is valuable. The second way is that you can ask in the same way you ask for other code to get CodeQL code out of the box, like get all the paths to the inner HTML property. I'm looking for a reflected cross-site scripting here. This code is given to me. I can run it, and I can go to the same result where a pen tester will go, for example, or a developer interested to find out if the inner HTML property is exposed. And finally, before we close the security chapter here, we have some code that, you know, I want to get explanations for. I don't want to go to the documentation. I don't want to search online. You can ask, what is this code doing? Especially for languages that you are not familiar with, like CodeQL, for instance. And another way we use it internally is by developing this language using AI pattern recognition. We specialize in open source, and open source code is gigantic. Instead of us reading open source code and developing libraries so that developers can pick problems out of the box with CodeQL, we give it to AI. There is pattern recognition going on, and some real vulnerabilities were found, like one in Gradle that we publish in this advisory database that is behind so many things. It's open source, this database, and there are so many products that consume it, like, for instance, Dependable and other more commercial ones. Okay, quick summary. CodeQL supports 10 languages. It's community powered, and there is AI modeling behind it. Let's now go to the third case, developer training. This is very useful. Let's put ourselves in the shoes of a developer that, you know, same code as before. The gentleman at the front said, you know, there is SQL injection in line 23 in here. If you Google it, it's perfect, yeah? But you are going to arrive in somewhere that is not bespoke to your code. This tutorial, this Stack Overflow post wasn't about your exact code. So you can ask, explain SQL injection to me with examples. So for example, you can get some examples that are customized in you more than the public material is. And then you can go the next step and ask, you know, don't know if you see that, can you tailor your examples on my own code? I'm struggling to see the connection between the theory and the practice. And your code is suffering from a specific variant of SQL injection. So you can go very specific in asking these things. You don't have to be in the training mode. You can be in the same environment like before. You code for your company. You found a vulnerability. You can ask training questions. I'm asking this all the time. Give me a training example. Give me this, give me that. So this is very useful for developers around the world. Let's see the next one. Security guidance. And I have an asterisk here because it's the first time we are going to ask for something beyond code now. Okay. We are inside GitHub. We are in this project, Bootstrap. I'm not a maintainer. It doesn't belong to me. I'm just navigating to their repo here. And maybe this is a project that I'm considering to have in my tech stack. I want to have it in my supply chain. What they do is amazing. What is the number one question we got asked when we hosted office hours with open source projects that you know when you use? It's the question, how would you hack me? What can go wrong with my project? Here at the top, we have Copilot for the web, which is a nice icon you have. And we can ask this question. So, what is my attack surface, or how can you hack me? And this is super useful because you can get this short list of things you have to be careful of if you consider this project in your supply chain, or maybe this project belongs to you and you want to develop some extra rail guards around it, or you want to develop some training for people that are gonna use the sidebars in a way that is gonna introduce cross-site scripting, or this model here is gonna be prone to this and that. So this is another way that the gap can be bridged. And this is super helpful because you don't need to ask someone. This someone needs to see your code, needs to learn everything there and start from zero. This is amazing. Let's be a bit more advanced now. Fuzzing. So what we saw before, the SAST stuff, is an inside-out approach. You have the code, you read the code, you find what is wrong statically with the code. Fuzzing is something that you can do to test your code for security when your code is publicly available. Imagine you have an input box asking for a username and a password, and instead of adding a username and a password, you can throw millions of inputs there to see some behaviors. Maybe you can cause the program to crash. Maybe you can cause it to be delayed. Then you know that something is wrong behind the scenes. How can someone do that without being a security expert? I just changed the code here, but it's not important to make it easier. So if I ask, can you fuzz? Maybe the answer is no sometimes. I'm not an expert, blah, blah. You can always throw your how card. How can someone do this? Or it's like you go to ChatGPT and it's like, hack this. No, how will you hack this? So we got a response, here's how you can do it. I'm gonna give you some code. This code is creating the automation, the fuzzing harness for us, which is something that it will take some time. But what really will take time will be to come up with quality hacking strings. So this is something that also the security people in the room or who are watching us online, and please feel free to ask your questions, are gonna be benefited from. So can you generate fuzzing strings? I would like to have a wide variety of inputs that are both invalid and unexpected. And this is good because so many engagements with security people are getting time consuming in this exact point. And at the end, you see in the blue text, this auto-generated text. How can I use these fuzzing strings to test my application? This blue at the end is auto-generated, and it's designed to keep the conversation going. Now, the number one question people ask about Copilot is regarding privacy. And it takes different forms. Are you gonna take my code and give it to others? Are you gonna learn from my prompts? Are you gonna take my code and maybe do something bad with it? Other people, even if it's not suggested to them, maybe they can have exposure to my code. The answer is no. So when you have a business or enterprise license, we don't save anything. And the only thing we get is the prompt that travels securely. We read the prompt, we give you back the answer, and then the prompt is being dropped unsaved. When you have the individual license, you have the chance to opt in or opt out at any stage from the Copilot as a product. And there is more information here in the Copilot Trust Center. You can learn in these areas: security, privacy, IP and open source, labor market and accessibility, dozens of questions with answers. Back to this initial statement that there is one application security specialist for every 100 software developers, and how we are doing to minimize this gap. Before we did some more on this with a summary, let's see a survey. So we asked 500 developers that are based in the US and they work for US-based companies of 1,000 plus employees. And these developers had experience between 5 to 10 years. So they are not junior, they are not super senior, they are people who code. Okay, how do you spend most of your time daily? And you see 32% is writing code, which is good because this is how they make their money. 31%, just 1% below this, finding and fixing security vulnerabilities. These verbs are reactive, are not verbs that you start left, okay? And then some other stuff like getting feedback and so on. And the question was reverted then. So, okay, if you save some time with the AI tools, how would you spend this time? And you have with equal answers, 45% being code reviews and security reviews. Remember at the beginning when we saw the Mercado Libre saving 50% of their time with AI coding tools? This is where I'm going after. So they know they need to do something more with security. And this is a nice way to use the time. Like it's a review, you know? It's not something wow. And it happens on the left. It happens early on. And the final question was, how many of you are using coding tools already, either inside or outside of your job? 92% was, yes, we use them. And this is nice because maybe some of you here today will be like, we are not there yet and it's not time for AI. Okay, maybe it is. Okay, so AI is indeed transforming how developers approach their day-to-day work. Today we saw 4 ways that we can do this. Like for instance, writing safer code by giving the right context in the form of a logic so that your LLM makes the probabilistic elements it comes with in a more narrow approach before code is suggested to you, with a big disclaimer to always test your code, including the code that has been suggested to you. The second way is to find security issues, either by actively using a SAST tool to code like SonarQube, CodeQL, and so on, or by using the code passively. We have AI behind the scenes nowadays. Developer training, tailored examples based on the specific vulnerability variants your code is vulnerable to. And finally, security guidance when it comes to those bottleneck cases that developers might hate working with security people, and security people might get time consuming when producing them. However, there are more opportunities in AI for security, such as threat intelligence, where you have to ingest a large amount of information in order to do something. With AI, you can prioritize what you can do first. Malware analysis comes down to pattern recognition so that you can understand if the false positives are positive positives, true truths. Then you have incident response, where you can be faster in detection. And when it comes to the IOCs, indicators of compromise, you can be very specific on what you ask for as an IOC. Pen testing, similar to what we see at the end with writing your own scripts, producing your own fuzzing stuff. SecOps, policy automation is something super useful. And finally, generating reports in the way that maybe you can write essays nowadays in ChatGPT. I want to show you something that I'm very, very proud about. So some of you were in my previous talk at 11 a.m. Back this morning, some others not. But there's a game we created at the lab that is a huge success. Not good. It's a huge success among developers. Numbers say, not me. So let's see how it works here. You go in this repo. You can play for free inside code spaces where you have 60 hours for free every month. And every level of the game has the same file structure. You are given a code file. This code file has code that is functional, but it can be vulnerable. And initially, the unit tests are passing here. But you are given a hack file that initially is failing. It's negative unit tests, basically. And these negative unit tests, they have to pass. You have to make the hack file to pass in order to progress to the next level. You are given a hint and a model solution that is very lengthy so that we can help you to learn. There are 2 seasons. The second season is community contributed, so it has more variety than the languages that I know to produce the first season. So the first season has Python, C, Python, JavaScript. And season 2 has Go, GitHub Actions, JavaScript, and Python. So you get a good variety. Finally, my name is Joseph. I'm part of the security lab, as I told you in the beginning, and I love to create content for developers around the world because I feel that not many security experts or specialists, I don't like to call me an expert, do so. Many security people are like, this is how I'm gonna hack you, and this is what I'm gonna do, and your code is bad. I prefer to speak as a developer for security. You can follow us at the GitHub Security Lab on X, where we publish our latest security videos, security findings, education content for developers, blog posts. It's a good mix between security stuff and non-security stuff. And with this, I would like to thank you for attending this talk today. And I'm sticking around for your questions. I'm in the event during this time.